We begin this section by defining something called a perpendicular bisector. Now, we have already had definitions for both the words perpendicular and bisector. Let's just recall some things about that. If I have a segment, here we have segment AB, if I wanted to construct a bisector of that segment, a bisector is something that divides things into two congruent parts. And so if it needs to go through the midpoint of the segment. So if I construct the midpoint, there's point C is the midpoint of segment AB. So segment AC is congruent to segment CB. Then any line that goes through that midpoint is a bisector of that segment, and it could be a line or a segment or a ray that goes through it. So this is a bisector of segment AB because it divides it into two congruent parts. Now notice that when it's a bisector, that doesn't really have anything to do with the angle that it intersects the line with. That angle could be anywhere from greater than 0 at less than 180. It could be any angle at all with which it intersects. As long as it goes through the midpoint of the segment, it's a bisector, dividing the segment into congruent parts. On the other hand, a perpendicular is a line or a segment or a ray that intersects another segment at 90-degree angles, at right angles. And so here I have a perpendicular segment to segment AB, and that it can be perpendicular at any point along AB, even at the endpoints at A or at B. As long as it intersects it at least one right angle, then it's perpendicular to the segment. Now, we could have a situation where we have a perpendicular line that also bisects the segment, a perpendicular that goes through the midpoint of the segment. So it does two things. It bisects it and it is perpendicular. And so we refer to this segment as the perpendicular bisector of the segment. And so here's our first definition here. If a line is, and it could be a ray or and it could be another segment, is both perpendicular and bisects a segment, then it is the perpendicular bisector of the segment.